It should be clear to you that example 3, handler response.go here, is a hybrid server. There is a customized part which behave like an echoer, seeing hello, responding with hello world show a message. So we have to define the hello handler there to do the job. There's also a general part, which is exactly the file server, so we're using the existing code in Golang for the purpose. And in the code walkthrough, let me start with the line of code in the example that we have not yet overviewed. It's the HTTP listen and serve API. Now we've seen this before in example 2, but this time the second parameter in listen and serve, we're actually setting it to nil. If I go back a little bit to the code, you see, this is the line of code that we have not yet touched upon. Okay. First parameter in example 1, you know that this is where the port number is, and this is where the server should be sitting at. Second parameter in example 2, we're giving it the handler for the URL that's coming in, and that handler is the file server. But in example 3, we're actually setting it to null, meaning we are not actually specifying who the handler is for the URLs that's coming in. So what happened there is, in Golang, there's a default handler if that second parameter is set to nil. And that default handler is called the default serve mux. Okay, so this thing here is essentially a demultiplexer. So it's looking at the prefix of the URL and deciding which handler we pass the URL to. The reason that we need to do this is because of this. Example 3, this server here is multifunctional, multi-handler-ish. So in case the prefix says /hello, we pass it to the hello handler. In case the prefix says simply /, then we pass it to the file server. So you see here, the default handler is very naturally a demultiplexer, which judge on the prefix of the URL and decide which handler to pass the URL further to, meaning which process we would call when we receive a specific HTTP request. Okay, so the demultiplexer checks the URL prefix in the incoming HTTP request and then determines which handler to forward the message to for further processing. To associate the prefix with the handler, we call this API handle. This is one of the most important API to create a hybrid web server because it does this. So here's an example. Calling handle. First parameter is the prefix /hello. Second parameter is the handler of the request. So handle here is creating a prefix handler mapping and insert that into the default sermux. So in default sermux, what's maintained is essentially a table of all these prefix handler mappings. Now, HH here is the handler. Okay, the native form of calling handle is this. First parameter still just the prefix as a string. Second is usually the entire code that you want to apply on the HTTP request that's coming in. Now, that entire code could contain multiple lines. So if we type up all the lines here, it's going to look really long and dirty. So it actually makes the code confusing as well. So what we do more often is this, calling the handler func. So this handler func is actually a converter. It converts a function that we defined earlier and then generate a handler of that function. So that is essentially an interface, and we keep that in a variable HH. And this HH can then be used by the handle function here as the second parameter. All right, so as a result, when the URL starts with /hello, it's going to call the hello handler function. Okay, similarly, let's take a look at another example using handle. So / here, the prefix is being associated with This handler. Now in this case, you're seeing the more native use of handle. So in case the prefix matches slash, we're just going to call this function, HTTP strip prefix. Strip prefix is another API defined in the HTTP package, which is right here in server.go. So let's jump to the source code and work it through. So right here, strip prefix. It's taking two parameters, prefix and h. Now the way we're calling strip prefix is this, slash, comma, fs. So that is also saying prefix, when we're calling it, is slash. And h is fs. And fs, if you recall in the example, we've already generated, that is the handler of the building file server. Now let's walk through the code. Well, in fact, there's only just one line of code, right? So, one call. It's an if condition, essentially. So what we're doing here is to try to match prefix with an empty string. If it's empty, then we simply return h, the handler of the file server. So that is saying if we put empty string there for the first parameter, whatever the handler in the second parameter is going to be returned to the handle function. And so matching that particular prefix in that handle function will be calling the file server. So this is a way to trickle the service down to the file server service. But hey, we're actually using slash as the prefix, so it doesn't match the empty string. Therefore, we are returning this instead. If you look a little bit closer, it's in fact just one line of code, or calling just handler func once. So this is parenthesis, and this is the ending parenthesis of the handler func. So what we're doing there is to convert the whole thing here, starting from func parenthesis w all the way to the end here, and return the handler of this function here back to the handle function. So when we match slash, we'll actually call the whole thing here. And inside the function, what's defined? So the beginning is right here, and the end is right here. It is essentially, again, just the if condition. All right. So what we're doing there, calling strip prefix slash, comma, fs, is essentially when we match prefix slash, then we call these, this block of code. Now what do we do here in this block of code? Let's walk it through a bit more patiently. So strings.trim prefix. And it's getting r.url.path. So r is the HTTP request incoming. So we take the URL part of it and we take the path part of the URL and then try to strip slash off the path of the URL. All right. So trim prefix is trimming this off the beginning of the string. And we'll actually assign the URL without the slash at the beginning to variable p. Now the if condition is to check this. If size of the p is less than the size of the original URL path. If it does, then we do this. Now if you look a bit closer, what we're doing there is to create another request, R2. So this is a new request struct, and then assign most of the values in R2 with the value in the original request. Now we will be a bit more careful with the URL part, so allocate memory for the URL and copy the values of the old URL over to the new URL, but reassign the path part of the new URL such that it equals p. So that is also, hey, if you recall back in pa8, what you're doing there is essentially what? Grab the path and then remove the slash at the beginning so that you could look in the file system for this particular object that being requested. So this is doing exactly the same thing that you're doing. So h.serve HTTP. So h is the file server's handler. So calling the file server and then calling this serve HTTP. This is the main function. Yeah, grabbing the object and then returning the object as an HTTP response. So this time we are using the new request as the HTTP request instead of the one that's really incoming. And then, hey, if this is not true, the length of P is not less than the length of the path, which means maybe slash is not really the prefix of the path or something else, something really odd. Then we are yet to return to the client saying that, hey, the thing you're looking for, we cannot find it, so not found. So you see strip prefix here calling the not found function call. All right. Luckily, not found function call is just slightly above right here, line 2029, because hey, you guys need to try to customize the not found message back to the client. So let's see how the default file server is sending the not found message. It's actually here, right? So it's calling error, and then it's printing exactly this string, 404 page not found. Okay, and the status line should be 404 not found. Okay. So you see, perhaps you can try to override the not found function call here so that you borrow the strip prefix structure, and override strip prefix, and so that you take the URL and then you strip the slash of it, and if you do not find the object, call the overridden not found function, and in that you print, or you return just file not found instead. That should give you some idea how you could build a customized file server. By that I meant the file server there returning a customized not found message. Well, if it doesn't quite inspire, then feel free to Google around and see if other programmers have tried to do the same thing, trying to generate customized not found message and send that back to the browser. But now, let's move on to demoing Poly's pa8.go. So Poly has also two versions. The version pa8.go is the plain string solution, and the pa8-http.go solution is to borrow from the existing code. Okay, and the binary again available from the same website. All right, and let's start with the pa8.go, the string version. Okay, it's now running. And that's ask for a file that's existing, server test.html. Okay, working. And let's try a file that's non-existing. txt. There. File not found. Okay. Now let's also try the HTTP, the one that's borrowing the existing file server's code. Okay, start it. Let's again start from getting a file that's existing. Okay, this time getting the source code of string response.go. And let's try, drums rolling, an arbitrary file. There, file not found. Okay, so let me show the code size. The HTTP version shorter, while the string-based approach longer. That's it, pa8.